All right, so as Ian said, this is the Things to Know About AWS Lambda webinar. A little bit about the agenda. Chris and I are going to introduce ourselves, and then I'll say a quick blurb about IOpipe, and then as Ian said, we're going to answer 5 of the common serverless questions that we've been getting running up to this webinar, and then we'll have an open Q&A at the end. I'll go first. I am Cassandra Perch. I'm a DevRel engineer at IOpipe. I do a lot of developer relations work, some content, basically just, trying to interface with the developers. I'm an IoT hobbyist and author. I'm an engineering student, and I have a computer science degree, and I'm a fan of all things serverless. And I'm going to turn it over to Chris to introduce himself.
Hey, everybody. My name is Chris Munns. I am a senior developer advocate for serverless for AWS based in our New York City office. I focus pretty much all day, every day on all things Lambda and API Gate related and things like that. My role is pretty similar to Cassandra's in terms of building a lot of content, doing a lot of talking, and helping developers understand how to best use products such as Lambda.
Okay, so I'm going to talk a little bit about IOpipe. Most of you either found out about this webinar through AWS or hopefully through our blog series, but just to go over it, we are a applications operations for AWS Lambda. We offer you a 10,000-foot view of all of your Lambda functions, and we have custom metrics, alerting, tracing. You can debug into, you can drill down into single invocations and go as granular as you'd like. And it helps to investigate performance bottlenecks, memory leaks, all sorts of things that could be going on in your Lambda function. If you're interested in learning more, check out iopipe.com. And with that, how to ask questions, like Ian said, if the Zoom chat, you should have a button to pop up the chat if you haven't already. And our moderators will select questions to ask us once we've gone over the 5 existing questions. And again, don't ask for direct comparisons between serverless providers, and please don't ask questions involving the AWS Lambda roadmap, things like when will you launch this or that or the other, because those questions will be passed over. So let's get started. Our first question is, how do cold starts affect the performance of my AWS Lambda application, and how can I mitigate that? Chris, I'll let you start with that one.
Great question, and definitely one that comes up incredibly often, which is why I think it's apt that this is the first question we address today. So for those who are not familiar, the concept of a cold start is effectively something that you might see when you go to execute a Lambda function for the first time ever. So after you've updated code or first created a Lambda function, or occasionally as your Lambda function scales behind the scenes. And so, yes, there are servers behind serverless, and we here at AWS take care of running those for you. And so basically what happens is when a Lambda function is executed, we look to see if there are hosts that are basically behind the scenes, or capacity, I should say, that are aligned or allotted to that function existing already. If not, what we do is basically grab some compute resources, pull your code down onto it, start up the bootstrap environment for that code, and then execute your handler. And so the first time, again, that you do this, either with a new function or with an update to a function, or occasionally as you scale, you'll see kind of a slower bit of initial response time. Now, when we're talking slow, we're typically talking in the hundreds of milliseconds of delay, not in the many seconds of delay. And factually, cold starts actually impact less than 0.25% of all invocations. So less than 0.25 of all invocations in Lambda are impacted by a cold start. And so it's important to know that these exist, but again, for most people under a pretty even application load, you're not going to run into these that often. They kind of disappear out into kind of the TP99 of your performance graph. So that said, how can you mitigate them? How can you maybe mitigate potential pain points from them? And I think that's really the best thing that we can talk about today. So when we go and pull down your function, which your code is stored in S3, and then brought down into the compute resources, we basically have to take that entire deployed artifact, unzip it, and then go and execute it. And so one really smart thing that you can do is make sure that your deployable artifact is actually kept, what I like to say, the right size. So this means that you haven't included a whole lot of other functionality, you haven't included a lot of other dependencies potentially, and that code is as streamlined as it could be for the use case given. Now, when I say for the use case given, one of the other key things that you can think about from the Lambda perspective is how you want to have your functionality distributed over more Lambda functions versus less Lambda functions. So for example, let's say that you have an API-based workload, and your API has maybe 10 different API endpoints as part of the same overall API, and various methods and handlers as part of that. Instead of potentially including all of those into a single Lambda function, instead of even maybe potentially including all of those into the same deployable artifact, you can see improvements in having those actually more distributed across individual Lambda files, so individual text files for at least Node.js and Python, and individual jars if we're talking about Java, as well as binaries for C#. And then again, thinking about splitting it down even further, again, depending on complexity in your team. And so what that will do, again, is kind of minimize the impact of how much data we have to pull down and make available for your function to execute. And so again, thinking about keeping those streamlined, thinking about keeping the dependencies to a minimum are some really key benefits to it. Another one that's really key is around VPC, or virtual private cloud. So when you go to launch a Lambda function inside of a VPC, we have to attach what's called an ENI, or an Elastic Network Interface, to it. And that call to the VPC API effectively to create and then attach that ENI also can add a little bit of latency during a cold start. And so our advice is, if you're not going to access resources inside of a VPC that you control, do not launch your Lambda functions in a VPC. There's literally no benefit to it. Lambda functions can't be reached directly over the internet. The infrastructure that they run on is secured by us. And so whereas with EC2 or even container-based workloads, you do care about the networking layer, with Lambda, it's not something that you should have to care about, again, unless you are going to run, say, your own databases or queues or other technology inside of VPC. So I think that's kind of the best advice there.
Yeah, definitely. I think you covered just about everything I was going to say as well. Yeah, just make sure to spread those Lambda functions out across several files, like Chris said, so that when they go to pull down your code for a cold start, it goes faster. Let's move on to the next question. When would I use containers for my application, and when would I use serverless? Chris and I were talking about this question, and it turns out we may have different answers. I'll let Chris go first, though.
I was going to let you go first, but okay, I'll take the opportunity just so we can move forward. So again, I come from an incredibly biased mindset on this, and that it is kind of my day job to think about it. But for me personally, I believe that taking a look at using serverless first for a new workload makes a lot of sense. The only reasons in my mind that I could think that you would want to pause and think about it, or maybe not go with a serverless model, is if you know for a fact that your workload is not going to fit into some of the constraints or limits or paradigms of Lambda today. So for example, Lambda has a 5-minute TTL, or take that back, a 5-minute basically max timeout that you can set for your function execution. So for certain types of workloads, certain types of media processing, transcoding, certain types of batch computing where maybe you can't break it down into a smaller batch, that's going to be something that's not going to fit really well into Lambda. The other is if you need to maybe use a programming language that today isn't supported or isn't supported well in Lambda. So if you have a PHP or Ruby application, and that's kind of your language of choice, it's going to be a little more difficult for you to make that run in Lambda today without maybe using some third-party kind of shim tools. And so for right now, while those aren't supported in Lambda, containers are going to be your best bet. Turn over to Cassandra for her thoughts on this.
Yeah, so so our thoughts are similar, but they take slightly different slants. So I view serverless as a tool in an architecture, and containers as a tool in an architecture. And while I definitely agree that a lot of things can be solved by serverless, there's certain situations where containers are going to remain useful. I find, especially if you want to maintain a very granular level of control, it's a trade-off. So you have to do the extra work to maintain that extra level of control when you're using containers. But that's what you get. Whereas with serverless, the trade-off is you have less control over your environment, but you do have the ease and capability to just deploy code and have it go. So that's mostly my view on the situation is it's about control, and it's about making the trade-offs for each one. So yes, if you're using a language that isn't supported by Lambda out of the box, probably a better idea to go through a container. But also if you want control, or you have outside influences that basically don't allow you to use serverless yet, certain security protocols, things like that, containers are still going to be one of the best ways to do that. However, that is quickly changing. Serverless is becoming more and more robust every day, and my answer is going to continue to evolve over the next few months or years.
So here's my reply to that. When would you use virtual machines?
Almost never. We've gotten to the point where containers have kind of supplanted virtual machines, except for very small edge cases involving either machines that, oh no, that doesn't even apply anymore. So no, just very few edge cases that I cannot think of off the top of my mind for virtual machines.
Okay, great.
Okay. Next question. What architecture considerations would I need to make when moving to a serverless model? I'll start with this one since I've thrown the last two at you, Chris. Basically, a lot of people think about serverless and they think, okay, I'm just going to move all my code over to serverless and everything's going to be fine and it's going to be performant and great. There are no magic wands in web development or any form of programming. And it's truly the case with serverless as well. You have to think about a lot of different things. For instance, whatever database technology you're using, will it play well with serverless? Will it play well with possibly getting tons of writes at once from many different sources? Will it be able to keep up with your serverless architecture? There's a lot, so serverless only really encapsulates the code that you're running. You have to think about all of the third-party peripherals that you use in your application in order to create a truly performant serverless application. If you're using an old SQL database that can only take a few reads at a time and spends 3 seconds returning your queries, your serverless app isn't going to be any faster than it was before. So that's really what I'm thinking of. Is you have to think outside the code when you think about moving to serverless, and you have to think about all of the things that code talks to and make sure they're going to work well with the new situation as well. Chris?
Yeah, I think that's a lot of good advice, and I would say that there is a number of things that does change with serverless, and there's a number of things that don't. So like the things that don't are typically the things that you do at the code level. How you think about writing your code, how you think about using code level functions or classes, or typical design paradigms that would exist in that. Even things like threading and forking your processes inside of your serverless functions, that stuff stays the same. I agree that from an architectural perspective, you really do end up thinking a lot more about the decomposition of your application. And I think this is one of the things where I see developers maybe not necessarily struggling, but it's the biggest mind shift is this event-driven model that we see in serverless. It's thinking about what are all the different things in my application that could be an event or that should be an event. I think it's also making use of, at least for us here at AWS, some of the other tools and technologies that exist. So for example, things like Kinesis, things like how SNS can be used to pass messages from one service into another into a Lambda function. And so, I think what I find is good advice for people is to retreat kind of back to that old school model. Maybe if you have a computer science degree and you've ever taken any sort of kind of user to code mapping type of projects where you had a kind of a flow chart or a UML diagram or something similar, and think about how you could go back to using a model like that to help you define your architecture. I think another one is that you hit right on the head, Cassandra, is thinking about how you store data and where you persist data. Some people have gotten really used to languages and tools where doing in-memory cache on a web server, while not the best practice, was something still that people did. In the world where you have Lambda as a compute resource and you can't necessarily count on any sort of affinity or stickiness to underlying hardware, that becomes something you have to think about pretty differently. And so understanding how different caching tools work, even things just like a memcache or Redis or something similar, becomes a little bit more key, I think, in this model than it has traditionally for, say, a somewhat atypical 3-tier architecture.
Great. Cool. All right. Next question. How do I manage concurrency in my AWS Lambda applications. Is there such a thing as too much concurrency in this context? Yeah, I mean, yeah, I'm gonna let Chris start with this one, actually. Sorry.
Yeah, so we'll start with the first part of this, and then maybe we'll run back up to the second part. So how can you manage concurrency? So today there really isn't any sort of lever around concurrency with AWS Lambda at the function level. Where you do get some aspect of control of concurrency can come from how it is that you are invoking Lambda. So today in Lambda, there are kind of three different primary models for invocation. There's a synchronous and an asynchronous model, and then a streaming model. And if you look at the various services that integrate with Lambda today, they'll integrate across one of those three models. So for example, API gateway, you're typically using it in a synchronous model. So you're going to call an API endpoint, and you're going to expect a response pretty immediately. With things like S3 and SNS, you have an asynchronous model. So you're going to throw calls at Lambda, or you're going to throw data into one of those services. It's going to invoke Lambda. And when the response or when the work gets completed from an application perspective isn't something that is you care about as much as you do in a synchronous model. And then in the streaming model, you've got products like Kinesis and DynamoDB that are basically going to kind of fire hose data at Lambda, or fire hose requests at Lambda. So when it comes to thinking about concurrency for each of these, some of it comes down to what can you control in those invocation products or invocation services. So with API Gateway, we do have usage tiers and throttling and things that you can do for people who are making requests or applications that are making requests against an API Gateway. And so you can use those to do some amount of concurrency throttling, as it were. With Kinesis, you have the ability to control the number of shards that exist in your stream. And now part of this is kind of related to the amount of data and records that a Kinesis stream can handle at any point in time. But it does give you the ability basically to tie back that a single Lambda function is only ever going to be executed at any point in time from an individual stream. So you do get a little bit of concurrency control with something like that. But for S3 and SNS, really this is where you have to think about, going back to the previous slide about architectural concepts, what it is that's on the other side of that Lambda function. So is it a relational database that might run out of connections or might easily become overwhelmed? Is it a third-party API that you might be calling that might not be able to keep up with your load? And I have seen people maybe presume that they're talking to an API that can scale as well as they can. And if it's a third party, you may find out that that doesn't work as well. And so there are some controls in some places. There's some places where there aren't as much control today. This is also where you want to think about how you handle things like retries and failures. It's something actually that step functions helps with, that having a dead letter queue can help with for Lambda functions as well. And so there's a lot to do there. And the second part is there such a thing as too much concurrency? Again, I think it depends on what's on the other side of that Lambda function. So, Lambda is built to scale through massive concurrency. We have customers doing some really high throughput concurrency applications today. Again, you want to look at kind of that full stack of what exists kind of throughout the kind of life cycle of a request or life cycle of an invocation at both what's going into that function and what's coming out of that function, and understand, is this thing going to scale behind the scenes?
Mm-hmm. Yeah, and on the bright side, and I think you kind of hinted at this as well, one of the good things about Lambda is concurrency is sort of built in. So if you have a Lambda function and you all of a sudden it gets a huge spike in traffic, AWS handles scaling up that Lambda function for you. You don't really have to think about it from that perspective. So you have to think about optimizing your code, but that's kind of one of the benefits of serverless as a whole, is you can focus on your code and let the infrastructure be dealt with by a provider. And so it's kind of nice to see the ability for a Lambda function to scale up that easily.
Yeah, I think you bring up a good point here. I mean, I think there's one thing where people assume that they're going to have massive concurrency, and history shows us that many people build applications that don't necessarily have that. But the fact that you don't have to think about the concurrency, or at least scaling the concurrency capabilities of the compute layer, means that you really can focus on the stuff that's either at the front of that or the back of that execution. And so at least it's alleviating some of the burden of you having to think about in the happy future of where you do have to reach some sort of massive scale.
Exactly. Cool. All right. How do blue-green deployments help my serverless application, and does it differ from other web applications? Just for some context, during Chris Munn's talk at Serverless Conf New York, they announced that AWS Lambda will have blue-green deployments in the future. So we kind of wanted to talk a little bit about this. How do blue-green deployments help your serverless application? It's very similar to web applications. It's the ability to set up a second Lambda that has, the newer functionality, and then you temporarily route to that new one. You allow the traffic to start moving over, and once you know it works, you just cut the old one loose. And I really think it's going to help in a lot of ways, very similarly to web applications. My only concern is managing blue-green deployments over hundreds or possibly thousands of Lambdas as opposed to one web application. But at the same time, I do believe the tools and the community will band together to create a way to do this in a way that allows DevOps and programmers alike to sleep at night. Chris, what do you think?
Yeah, so for context, and thank you for referencing my talk from last week. So last week we pre-announced something which is called traffic shifting and aliases for AWS Lambda, which will be coming here, in just a couple of weeks probably. And what it allows you to do is basically have a function where you've got two different versions. You assign aliases to versions, and then you can assign a weight to those aliases, such as you can have a newest version or newest alias of your function getting 5% of the traffic and the rest getting 95% of the traffic. And then you can basically turn that knob so that you increase more traffic to the new one, decrease traffic to the old one, and at some point, cut over between the two and, be completely on the first. What's nice about this compared to web applications is typically the web application, you're doing this kind of swapping between the blue and the green, or from a canary to a full pool, and there's different types of terminology you could use here. You typically do this either at a load balancing layer or at a DNS layer. Pros and cons to this sometimes. So for example, if you are doing things like sticky sessions with a load balancer, there's a pros and cons to that. Sometimes it can be good to have that ability to keep traffic always going to one side or the other, but sometimes it can cause you to have too much traffic potentially contained on an older version. With DNS, I think as everyone probably on this call knows, there's lots of problems with DNS. There's downstream ISPs that may not respect your TTLs. There's clients that don't respect TTLs. And so doing blue-green in DNS, at least publicly on the internet, can provide a number of challenges, and you might have to keep that infrastructure around even longer than you'd expect. I think what's really nice about the Lambda version is that you have to do nothing on the client side, or even on the invocation or the invocating service side to work with this. Basically, you set the weight for the alias, and then as invocations come in, we're going to basically shift traffic to that percentage that is even to that. Where it can be a little tricky is that there is no sort of stickiness to this. So if you were expecting, say, like an end device and an IoT workload to have some sort of affinity back to one version of the function or not, that's not something that would be supported in this workflow. But it is really good for giving you the ability to kind of slowly roll out changes to your Lambda functions for some value of slow, depending on what that means for you and your organization. Be able to test and be able to see kind of metrics and logs for the two versions in parallel. If you need to, say, roll it back, you can very easily turn the weight back up to 100% for your old one. If things look good, then you can just kind of turn that up to 100% as well. And you don't have to think about scaling down EC2 resources, DNS TTLs, making load balancer configuration changes. It really just exists at the function level. And so we think that people are going to see some really kind of interesting things that they can do with this.
Yeah, so it harkens back to the main benefit of serverless. You worry less about your infrastructure. Once this releases, you'll be able to set up those traffic shifts without having to worry about all that. That's kind of like one of the huge benefits of serverless. And it's really great to see Lambda continuing to raise the bar on that. And that is all of our prepared questions. So we have time for your questions. Things to remember, ask questions in the Zoom meeting chat, and no requests for product comparisons or AWS Lambda roadmap questions, please. Our moderators are reading the chat, and if one of them wants to chime in with a question, that's awesome.
Hey, Cass, this is Ian. Yeah, we have some really good ones that came in.
Okay.
So the first one is, I think this is going back to what you were talking about, when to use serverless versus containers. And so the question is, what are some situations where you want that the more granular control that you were talking about?
The most common I can think of is security issues and security protocols that are not yet covered by serverless providers. AWS Lambda is quickly closing the gap on that, but there are still some, and sometimes it's just internal company policy that you have to have control or something has to be hosted on premise. Those are mostly the times I would think of those are the most common ones I can think of. For something that's not constrained by that, I lean heavily towards serverless.
Okay, great. Great. So the next one that popped up here is, what's a good way to handle code that requires a lot of low-level dependencies?
Good question. Well, you know, we would definitely recommend that you want to minimize the amount of those that need to exist inside of a single function. So is there work being done or requests that are being handled in such a way that you can potentially break out some of the need for dependencies from, like, one larger function and potentially break it down across either individual functions that are individually executed upon, or maybe as part of a step functions workflow, you breaking that logic out even further. Beyond that, I think across kind of the industry over the last couple of years, developers have gotten themselves into a little bit of a pickle of, falling back on third-party modules when maybe they should be thinking about bringing some of that code into their own application. And so I have seen a couple of customers where they said, hey, you know what, we want to include this third-party module, but we only really use 10% of what it does. And so they might actually look at bringing some of that code base into their own code base and kind of treating it more core to their product. Trade-offs to that, obviously, various kinds of pros and cons. But those are kind of the different things that we see people do. One last bit on this, I think there's a really huge kind of growing concern in the security space around developers that are including packages and modules and maybe not necessarily keeping on top of security vulnerabilities that might exist in those. And so we'd really encourage you to look at some of the tools that exist out there for kind of inspecting third-party packages, keeping on top of updates. There's a number of tools out there. Version.io is one that will look at kind of open source repositories. Snake is another that looks at and kind of lists vulnerabilities based on dependencies. There's a kind of a whole bunch of those out there, but I really encourage you to focus on the security aspect of this as well.
Awesome.
Great. So here's another one for you. Do you have any recommendations for implementing HTTP2 using Speedy Library in Node and using it in Lambda?
Oh, wow. I think you might have me on that one.
Yeah, I have not done that in the Lambda context. I've only done that in an EC2 context. I've gotten it to work on an EC2 instance, but I have not tried it with Lambda.
So I'm not sure.
Is it not working, or is it something that you want to try and you want advice before you start? I'll give you time to answer in the chat if you're still listening.
Well, yeah, we'll give it some time to see if we can get some clarity.
Okay.
Perhaps we can go into another one and give that individual time.
Yeah, we can come back to that.
And of course, should that not happen, we can always follow up via blog post, or we can do it via email, right?
I could say right now that today officially HTTP2 is not necessarily supported inside of API Gateway. So for an HTTP workload that would be a request via API Gateway, it's not something that is capable today.
Okay. Let's go into another one. So here's one. How can Lambda be used, I guess based on your experience, for e-commerce applications?
Any way you could think of, really. So I mean, I think for so today Lambda is now part of our PCI certified services here at AWS, which means that we can support anything from credit card processing to all sorts of various kind of money database transactions that would need to happen on the internet and be certified and accredited at some point. We see customers today using this for web application backends, so powering kind of the very atypical CRUD interfaces that you will see for a website. That's incredibly common. We see Lambda being used for kind of backend microservices that might be on the backside of a transaction that's financial. So are you buying something? Are you selling something? Is there an inventory that needs to be tracked? So I think, of course, across kind of most of the workloads that I can think of that are in that realm, you should be safe to use Lambda. Again, given that they fall within the bounds of the limitations and kind of nuances of what Lambda is.
Great. So here's another one regarding concurrency that came in. Is it possible that the same container will handle 2 concurrent requests at the same time, or are they absolutely different?
Mm-hmm. Yeah, they are. A single container handles a single request at a given moment. So there is no concurrency at the container level. There is concurrency at the higher levels in the stack.
Great. So here, how about, could you please give an example of any popular application that has shifted from a manual server to Lambda server is what they say, but I think we know what they mean, and how it impacted their business in terms of infrastructure?
Sure. I think one of the best ones that I've seen comes from Bustle. Bustle runs a website that is kind of a media site for women, and kind of related topics. And they, back maybe a year ago, started making the shift of getting rid of all of their, what you consider physical servers. They're on AWS already, but basically all of the server management they were doing and moving to serverless applications. So, storing all the static assets in S3, having API backends via API gateway and Lambda. And for them, if I recall, I believe the number is they saw an 84% savings compared to their previous infrastructure, while still serving the same requests, meeting the same SLAs and so forth. And so for them, it was a fairly massive amount of savings, and then it's greatly reduced kind of the operational burden. There's just kind of a whole bunch of other case studies that are out there that you can read. If you actually go to AWS and Amazon.com/serverless, you'll see a bunch of those listed there. And we've had companies like Capital One move some of their properties to serverless for like websites, and also seen kind of some pretty significant savings. Just the other day, or I guess just last week technically, we put out a blog post talking about how Coca-Cola is using kind of the serverless stack of services that we have actually to power an IoT workload for their vending machines. It's actually pretty fascinating stuff about how they do some pretty cool logic with Lambda and other things. But there's definitely a number of customers who've done it largely for money saving reasons, but also to kind of reduce again the operational overhead of running that infrastructure.
And to harken back to the e-commerce question, Nordstrom is also using serverless, and they published a case study with y'all as well, right?
Yeah, very true. Nordstrom uses Lambda for a number of different places. It helps power a recommendation engine. It helps power some of their web properties, I believe. They've got a lot of different use cases for Lambda.
Yeah, so the person who asked the e-commerce question, you should probably take a look at the Nordstrom case study to learn a little more about what they did. And that might help fill out your question a little more. Okay.
Great. So there are more questions. I think this is more to you, Chris. From an AWS perspective, what are the top 3 use cases you're seeing for Lambda today?
Good question. The biggest by far right now is the processing of streaming data. So whether it be things like use cases in the ad tech industry where you're collecting beacons, or maybe you're doing click tracking, or kind of like user analysis, or you have some sort of IoT-ish type workload where you're collecting sensor data, and sending that kind of data in through a Kinesis type of service. That is today pretty much our number one use case that we see. The next couple ones that come out of that are media-related type workloads. So people who have image processing that they're doing, on the fly, or as part of, a customer uploads, say, an image, you need to resize it for them, or transcode a video with kind of S3 to Lambda. We see quite a lot of that happening for also like log processing and other kinds of like document processing. And then web backends. So people actually moving, again, web applications where they're relying on things like single page application frameworks like React or Vue to be the front end. And then they've got an API backend that's being powered by API Gateway and Lambda. That's becoming a really common way, especially in enterprises, which tend to have a lot of really basic internal websites. We're starting to see some really exciting stories come out of people saving a lot of money by moving to serverless web applications.
Great. Okay. Are there best practices established for tracking events through my serverless system? How can I trace a log event back further in my system to a previous function invocation? For example, Lambda A receives an event message, Lambda A receives an event, passes messages via SNS to Lambda B. How can I track an invocation issue in B back to an invocation of A?
Well, one of the first things I would look to is a pair of tools. X-Ray is great for tracking your requests inside the AWS system. So when you're talking about SNS and getting requests, from Lambda to SNS, and of course, bias, I work there, but IOpipe and X-Ray work very well together on these kinds of situations. And basically a good monitoring tool, be it the internal X-Ray or be it a third-party system like IOpipe, is really going to help you figure out exactly what's going on in your system, both from the 10,000 foot level and from the really granular level of what invocation exactly caused the error. Chris, any thoughts?
Sorry, I had myself on mute. I absolutely agree. No, I think you hit the nail on the head. So we are luckily on a webinar that's being led by the folks here at IOpipe, which is a fantastic tool for doing basically exactly what the question addressed. At AWS, we have X-Ray, which is something that can plug into a number of services and give you some of that information as well. And so, those are kind of the two places where I would start for something like this.
Okay, great. Let me see here. All right, how about this one? How are downstream services, such as databases, impacted by Lambda workloads that may increase connection count?
That entirely depends on the database that you're using. So that's what we mean. That's what we meant earlier when we were talking about architecture and how you have to think about these things. You have to look at your database and ask yourself, okay, how many concurrent connections can this database hold? Will I have to scale up my database to meet the needs of Lambda functions at nominal traffic, spike traffic, whichever? So it really depends on the database technology that you're using. Luckily, most database technologies are very forthcoming about how to either increase concurrency or what the limits are there. So I would definitely take a look at your database, whichever one you're using, and go from there.
Yeah, I think that's a good way to handle it. I mean, there are certain relational databases that are a little bit heavier about the way that you connect to them and have concepts around connection pooling and keep alives of connections. And then there are highly parallelized distributed scale-out databases like Cassandra, not the host Cassandra, but the database Cassandra with a C.
I've never heard that joke before.
I didn't even try to make it, but yeah, that are meant to be widely distributed, and so connected to them is a little bit of a different concept. I guess one thing I would say is, if you have an existing application and you're thinking about moving to a serverless application, there isn't a whole lot that should change about the way that you think about your application, the way that you're thinking about scaling your database, unless you're making just really, really heavy use of some sort of connection pooling technology. For example, PG Bouncer with Postgres. And I have actually seen people have Lambda connect to PG Bouncer before, potentially running on EC2. I don't necessarily think it's a necessary thing that you can do, but it is something that can help address it. But I would say that, if you have an existing workload, it has kind of an existing traffic pattern against it, it should be fairly easy for you to understand how to scale and tweak both the database and then the understanding of what you're doing from your application code so that it's not problematic for you.
Great. So there was a question earlier about how to handle code that requires a lot of low-level dependencies. There's a follow-up question to that, and that is, are there any tools that make packaging extra dependencies / packages into Lambda functions easier? For example, C libraries.
C libraries, I can't say that I have a really direct, straight answer for that. What I would typically recommend is that this is where you want to think about your CI and CD process. So creating your artifact, bundling your artifact, and making it available to Lambda, all of that should happen as part of a traditional CI and CD workload. And so for us here at AWS, we obviously have a suite of tools, which are called our code services, code build, code pipeline, our Git repository service called code commit. All of those can help you do this. That said, you could do the same thing with really any code repository technology combined with any sort of CI and CD tools. So whether it be a Travis CI or a Circle CI or a Jenkins or a Team City or any of those things, the taking of the dependencies, compilation of them if necessary, and then bundling up into the deployable artifact that you need to do should be fairly trivial to script and put together. And at least from us here at AWS, we're more than happy to help you figure that out if you're running into roadblocks. But there's pretty good existing patterns across all of the languages that we support in Lambda today.
There's also a good way to test that locally now. Instead of having to completely deploy your bundle to see if it works, with SAM, you can now invoke your Lambda functions locally, and so you can test your artifact before you deploy it.
Mm-hmm.
So
Okay.
could save you some time.
Here's another one. If I'm embracing microservices heavily, I may have a function calling another function to manage state. The first function now has to wait for the second function to finish and return the data. The issue with this is that the first function is billed while waiting for the second function to finish. How can I address this issue to save costs?
Mm-hmm. So we would actually discourage that type of pattern. This is actually exactly why we built step functions. So what step functions allows you to do is effectively have the ability for one Lambda function to invoke another Lambda function as part of kind of an overall workflow. Now, this is typically not a synchronous workflow. And in synchronous workflows, you would really not want to have Lambda call Lambda. But for asynchronous workloads where you've got to maybe do a number of bits of business logic that for, again, performance reasons or structural reasons or team reasons, they are individual components, what step functions allows you to do is basically pass information between invocations of functions such that you can kind of maintain some stateful information between them. And so for really kind of going to the way the question was worded, my advice would be take a look at step functions. You can put step functions behind API Gateway. You can put step functions, I believe, behind SNS today as well. I think I might be wrong on that, but I think you can. And so that should help at least with a number of those kind of more common workloads.
Great. So it looks like that actually covers the questions we have.
If you have any more questions after the webinar, this is the contact information for both Chris and I, our emails and Twitter. So
we still have time. So we have some coming in. Definitely, please do follow up with Cassandra and Chris. But here's one that just came in, if you don't mind.
I don't mind.
What was the tool that allows you to test Lambda bundles locally again?
SAM. SAM.
SAM local.
Oh, SAM local, right.
Yeah.
Great. All right. I believe that that covers it. So everyone, thank you again for joining. Please do follow up with Cassandra and Chris as you see fit. And we'll do our best to go through some of the questions that we may not have gotten to through the things that came in through the chats, and we will follow up directly with you via email. With that, hey, thanks everyone, and have a nice day.
Yep. Thanks everyone. Take care.
Thanks. Have a
Thanks,
good one.
Cassandra. Thanks, Adam and Ian. Really appreciate the opportunity today.
Thank you,
Thanks for
Chris.
joining us.
Okay. Take care.